So we've all used the terminal. You enter a command with some arguments and the shell program interprets that, but it doesn't really see it as one full string. What happens first is it converts that long string into tokens, which are separate words that the parser can understand and deal with. And that's what we're going to do today in assembly. We're going to take a line of input, tokenize it, and then store those tokens in an array of strings. So let's get started. The first thing we have to do, of course, is get some input. So I'm going to allocate some RAM in the data segment. I'm going to call it buff. And I'm going to get maybe 128 bytes, so not so much. So this is where we're going to store the data that we read from the keyboard. But we also need to know this number here. Now we could hard code it like we did in the last video, but we should really get back to what we did in the Hello World program, where we calculate it at assembly time so that whenever we change this value, it changes with it. So I'm going to put buff size here and I'll put an equal sign and then a period and then minus buff. And it looks a little bit cryptic, but what's happening here is it's going to get the difference of the current position minus this position, which is 128. So it's just going to keep this value for us. So even if we change this to 1024, then this will automatically update. So I'm going to put it back to 128. So we have the location where we're going to save the string that we read from the keyboard, and we have the length of it. So now what we can do is copy and paste what we had before. It's in the description of the video, the exit, our print function, our string length function, and our readline function. So at the top right here, we really want to just read a line of data, and readline takes two arguments. It takes RDI, a pointer to our memory location where we're going to write that data that we read from the keyboard. That's buff. And then RSI is the maximum length that we want to read. And we'll just say that the maximum length we want to read is the entire sequence. So it's going to be 128, which is going to be in buff size. So we're going to load to RDI buff. That's where we're going to save that input. And then we're also going to load to RSI the value of buff len. Is that what I called it? Buff size. Buff size. And then we're going to call readline. And let's test this out. So I will step through. We can set our arguments here. This is the location of buff. It's an RDI. And the max length that we'll read is 80 in hex, which is 128 in decimal. So we'll click continue here. It does ask for input. That's a good sign. I'll put hi there and submit. And we did exit with code 0, so everything seemed to work well. We kind of got lucky here. Exit is right below. It fell through. So I'm going to put an explicit call exit here in case we end up writing code above this point. Now, it would be nice to see the data after we wrote to it. So I'm going to print it out real quick. So I'm going to reload buff to RDI, and then I'm going to call print, so that I could print it back out to us. We can make sure it was saved properly. Put hi there, and here it is. Hi there is printed out, and we still exit with code 0. Everything looks perfect. So we're loading into buff our line of code, and now we can actually start to tokenize it. So let's go through the overall process of what we want to do here. We're going to have a string. Let's say that our string is hi there friend. So we have 3 different words here, and we call it 3 different tokens. But right now it's sort of stuck in one string, and we want to convert this to one string per word, which would be our tokens. So the way to do this is, since we know there's going to be spaces between the words, we can just go through the string, replace each space with a null terminator, and then the second part of what we need to do is save the starting character's address into an array of strings. So if we start going through hi there friend, we get to the H at the start. So what we're going to do is write down that address into our array. So we have the start of that first string. Then we need to go through every character until we get to a space. And we know that's the end of the first token, and we change the space into a null terminator, and now that first token is done. Then we continue scanning through the characters until we find something that's not a space. In this case, it's the T for hi there. So we mark the location of the T as the second member of our array. So now we have hi in the first one, and we have their friend. Once we get to the space after there, then we convert that to a null terminator. And now the first member points to hi, the second member points to there. And again, when we print out that first member, it's not going to go past the null terminator. So we're really converting one string into many. In place is what you'd call it. This is an in-place tokenization. So after we mark that null terminator for there, then we continue until we get to another character. In this case, it's going to be the F in friend. And we're going to write that down. Now we're going to copy that address to our array. So we have an array full of hi there friend, and then we're going to wait until we get to a space or a null terminator. And this actually reminds me that there's a bit of an oversight here. When we call readline, we should really null terminate the entire string. So what we want to do is, if you recall, when we call system call read, which is rax0, the return value is going to be how many characters was read to us, and we just return after. So system call puts into rax the amount of characters read, and we're just returning. So that means that when we've reached this line of code, rax still contains the length of the characters that were read. So what I'm going to do is I'm going to load to RDI the buffer again, just to make sure that it's the right value. And then I'm going to move to RDI plus rax a0, which is a null terminator. So we're getting RDI, which is a start of our buffer, and we're moving the amount of characters that were read. And then we're going to put a 0 right at the end there. And we could put byte pointer here. That's what we're going to have to put. And we had an issue in one of the recent videos where we did a similar thing here. And really what we're doing is we're adding an extra character to that buffer. So we need to make sure that we leave room for this null terminator. And the way we'll do that is we'll just subtract by 1 our buff size to make sure that we have one more spot available for the 0. And I'm going to show the null terminator being applied to it because I think it's important to see it. So what I'm going to do is add a new little function here so that we can preview the stack memory very conveniently. I'm going to call it memView or something like that. And all we're going to do is take a look at the memory that we're writing the data to and then put the stack back. Because we're using the stack pretty often right here. Every time we use call or return, we're using the stack. So we don't want to change the stack too much, but we're going to use it as a memory viewer, since on the emulator that I'm using here, the x64 Playground, the memory viewer is the only way for us to look at memory conveniently. So I'm going to just redirect it to look at the buffer whenever we call this function. And then we can take a little snapshot and then it will return the stack back to the way it is. So let's do that. So let's save the position of the stack to a register. Then let's load to the stack pointer the buffer location. Let's add an interrupt here, which is kind of like a breakpoint. And then let's restore the stack from the R14 register, and then we return. So we save the location in R14, and then we use it as our previewer. We add a pause so that we have a chance to look at it, and then we'll restore the stack and return like nothing happened. So what I want to do is call memView right here, and then I want to call memView afterwards. So let's see how this looks. We click continue, we get our input. Hi there, friend. And you see right now we're in this memView. We read the line, and you can see over here, hi there friend has been saved to 402000, which is the location of buff. And one more time, we're only doing this because we are on a system here, or I'm on a system here where we can't really see the memory conveniently. So I'm just abusing the stack. Don't really do this on your system. If you're on Linux, you can use other methods in GDB or something like that to look at the memory. But we have our string, hi there friend. And then I'm going to click continue again, and we should see, well, we won't see anything because there's already a 0 since everything is filled with zeros, but it will append a 0 here after. So what I'm going to do to make sure that we can see it, I'm going to put a comma, and I'm going to put Fs here so that it fills up this memory location with Fs. And now we can see the 0 being added. So I'm going to put again, hi there, friend. And you see all these Fs, right? So the end of our string, this is what we were talking about here. There's no 0. On the low level, we really want zeros to be at the end of our strings, and that's called null terminating, as you probably know from before. So we really, the first thing that we want to do is add our 0. So if we click continue, then you see that we added a 0 here, right? Marking the end of the string and really making this into a proper null terminated string that we can very easily go through without having an issue. So that's kind of step one. We have our string ready to go. So now we know that we want H, the T, and the F. We want these to be entries into an array. So what I'm going to do is down here, I'm going to add another area called tokens. And I'm also going to make it 128 bytes. And this is going to be our array. And each member of this array is going to be 8 bytes long, which is a length of, for example, this piece of data. The addresses, right, on the system are 64 bits. So that means that every time we have a pointer to a string, which is what this array is going to be, it's an array of strings, or we could say an array of pointers to strings. Each member is going to be 64 bits long. So we have 8 into 128, which is I guess 16 that we can fit in there, 16 entries. Should be more than enough room for our testing, but you can of course make this as big as you want. And now we can start going through our string. So after we've read the string and after we've null terminated it, and we can get rid of this memory viewer right here because we know that the null terminator is added. We don't need to see that anymore. So after we verify that our string is in memory, let's actually tokenize it. So let's write a function down here and let's call it Tokenize. I think Tokenize should take 2 arguments. It should take the location of the string in total, which is hi there friend, right? And this is going to be, this is in buff right now. So we're going to pass the location of buff to Tokenize. And then we're also going to pass the location of the array that we want to build, which is tokens. So let's put into RSI tokens, and then we can call Tokenize. So Tokenize is going to have both of these values in registers. And since RSI is going to be used by all sorts of system calls and all sorts of operations, we're going to copy that array address into R15, which will make it a bit safer. And it's just going to be, we don't need to do a load anymore. We could just do move R15, RSI. So we're copying the array location into R15. And this should really only happen once, the first time we call Tokenize, because it's going to have to loop through our entire string here. So we need to kind of prepare for that. Let's do a tokenize.loop. So this only happens once, and then we'll consider this like the body of the function. So we're going to move now to R15, right, in brackets, because it's a memory pointer. It's pointing at the tokens location. We're going to move basically the address that we start at, which is RDI, right? So we're going to pass to Tokenize the start of our string, which is H, which is 402000, right? That's buff. This is the first character of buff, the first byte of buff. So we load that into our registers. We call Tokenize. Tokenize has RDI still pointing to the H. So we're going to add it to R15, which is pointing at the tokens array. So it's going to be member 0, right, the first member. And then we're going to add to R15 8. And that's so that we can get to the next member, right? Each member is 8 bytes. So we have to increment it by 8 bytes every time we add a member so that we don't overwrite anything. And after we do this, I'm going to add a mem view here, and I'm going to do return just so that we can kind of see what's happening. So I'm going to click compile, continue, hi there friend. And we see hi there friend is in the memory. We see it's null terminated. And if we click continue, then you see that 402000 has been added to right after the F's end. And it's a good thing we added the F's. It's a very easy way for us to see the memory. So we know buff filled the memory with 128 bytes of F's. We overwrite the start of it with our string as we wanted to, but we can see that right at the end of the F's, that's where tokens lives. And tokens now, that first array position, we could say that first member, the first 8 bytes, right? 1, 2, 3, 4, 5, 6, 7, 8 is the address 402000. So we could say that the first member of tokens, right? The array points to this location. Now, this is still one big string, and we want to split it up into smaller pieces. So step 1 is complete. We save the position of hi, even though right now it's still hi there friend. And now we need to make sure that hi turns into one mini string, and we don't want to copy it anywhere. Again, we want to put it in place. So what we want to do is convert this character, the space, into a null terminator. So what we need to do is make another function called like find end or something like that, where we can skip through any character that's not a space. So let's do that. So let's add it below Tokenize, just to kind of keep some of the functions that belong together. And let's call it find end. So what find end is going to do, we're going to pass it the same RDI argument, right? RDI is the one kind of keeping track of these positions here, at least for now. So find end is going to compare the current character to space, right? Because that's the one that we're looking for. It's hex value 20, or we could use a space. So let's do that. So we're going to compare a byte pointer of RDI so that it knows that RDI is pointing to one of these characters, and we want the assembler to know that we're only talking about a character. When you have a memory pointer, it could point to 1 byte, or it could point to 1 byte with a bunch of bytes afterward included, but we only want it to be the singular byte. So we compare the single character found at the memory position in RDI against 20 in hex, and that's a spacebar. Now, if it is a space, we're going to jump if equal, right? We're comparing those two. So if it's equal, if this is a space, then we're going to jump to return because we're looking for a space. So I'm going to put here find end.return, I guess just return. But if it's not a space, then we're going to increment RDI, and then we're going to jump back to the top. So when find end gets control, it's going to check the H, and it's going to say, hey, are you equal to a space? I could put this here, like in quotes to make it simpler. So he's going to say, hey, are you a space? You're not. So it falls through, right? You only jump if it's equal here, right? Jump if equal is this command. So if he's not equal, then we fall through and we increment RDI. So now RDI points to the I, and then we're going to jump to the top, right? And then we're going to compare it again. So we're comparing the I now to the space. And again, we jump if equal, but it's not equal, right? It's not a space. So we continue down again. We increment and we jump back to the top. So now we're pointing at the 20, which is a space. So we compare it. Is the memory address pointed to by RDI a space? And yes, it is. So now we jump if equal to the end here, and then we return back up to whoever called us, and nobody's calling him now. So I guess we need to add that. So after we add to the array, then we can call find end, right? Because we've added the H to the array, and now we can find the end of it so that we can know where it finishes, and we can add that null terminator. So let's call find end, call find end. So find end will move our pointer over to the space, and then we're going to convert the spacebar into the null terminator, right? To bookend the high, to make high into its own string. So let's move byte pointer, we're only talking about 1 byte here, to RDI, the value of 0. And let's see if this works. Actually, let's add a call memview here after so we could see the difference. So let's compile this, click continue, and put hi there friend. And we have hi there friend loaded in memory. We click continue. We saved the hi, the first token, to our array. And then let's take a look at this 20 here. I think it should disappear. So it turned into a 0. So we have hi and then our null terminator. So that worked well there, friend. So after we've converted this character into a null terminator, then all we need to do is move to the start of the next character and repeat the process. Then we save the T, and then we null terminate it, that one, and then we save the F, and we find the null terminator at the end, and then we quit. So the concept is here, right? We need to do a bit of cleaning up. Number one, this needs to loop. So let's just see what happens. Let us jump to tokenize.loop. Now this is going to be an infinite loop here. We're not able to break out anyway, but let's just take a look at what happens and see if it works. So let's click continue. Let's put hi there, friend. So we have our string loaded. We add our first member to the array. We null terminate. Let's see what happens next. We add now the T. Wait, is it the T? I think it's probably wrong. So 0, 1, 2. So we have a mistake here already. The second member in the array, we put it at the 0. So really, after we find end and we null terminate it, we need to increment RDI to move it to the start of the next string. Run it again. Hi there, friend. Continue. We add to the array. We null terminate. We add now to the array 0, 3. So 0, 0, 0, 1, 0, 2, 0, 3. So the T now, we have now hi in the array, and then their friend is the second member of the array. But now we need to go through and kill this next space. Click continue, and it does do that. So now our loop is really starting to do some work for us. We've turned this into its own little string, and now we've turned this one into its own little string. And then we add that now. 0a has been added as a third member in our array. Let's see if that lines up properly. It should be this character right here. So 8, 9a. So we do have our 3 tokens added to the array. Everything looks great. And then we click continue, and then weird stuff is going to start happening here as we eat our own data. Right now it's killing all of our 20s, right? Because it thinks that they're spaces, but they're just addresses. So we need to stop our loop from turning into a black hole. But this is the start of a good system here. Now there is a major bug that we need to account for. What if we have spaces all over the place? Hi there, friend, like that. Let's add some more spaces. Right? As you know, in code and stuff, spaces, they're removed. We only want there to be one space between these two, or we're going to have some weird stuff going on here. If we put the same string, oh, I forgot to put it. So let me do it with a bunch of spaces. So we have a bunch of spaces here, and we need to deal with this issue because this will cause all sorts of parsing nightmares if we don't deal with it initially. So we click continue, and we have 402000 added as our first token, but that's really a space. And the start of our actual first token is all the way over here where the H is. And if we continue to run this, then we did null terminate that first space, but it kind of doesn't make sense, right? We null terminated the beginning of it, which sort of just kills everything. And then we have 40201. So we've saved nonsense to our array now. We've saved a literal 0, so a non-string, and then we've saved a space into our array, and we null terminate that guy too. So as we can see, it's really not a good system. Our array is going to be full of garbage, a bunch of zeros, and then finally we get lucky, or do we? Let's see, 1, 0, 1, 2, 3. 3 is right here. So we do get lucky on this one, and we do have high in there, but we need to deal with all these spaces, all this white space, we'd call it. So really, the first thing that we should do is, instead of assuming that the data is good, let's skip any leading white spaces. So for that, we're going to write another function, and let's call it skip white. So we're going to skip white spaces. And what skip white is going to do, we're going to do like the opposite of find end, right? Find end wanted to go through our characters until it finds a space and then it returns. What we want to do is skip over all the spaces and return only when we find a character that's not a space. So we're going to compare a byte pointer RDI against space, just like in the last one. And if it's equal to a space, then all we want to do is advance. We want to move forward. So down here, we could put skip white.advance, and we're going to increment RDI to move forward. And then we're going to jump back up to the top, skip white. So we compare, let's say in the beginning, let's say these are spaces. Right now they're zeros, so let's say they're spaces. It's going to say, hey, is this a space? Yes, it is. So we skip to the next one. Space, yes. Skip. Space, yes. Skip. Are you a space? No. So after, if it's not a space, right? If the jump doesn't occur, then we know it's not a space, and we could just return. So we're keeping everything in RDI. We could, of course, move to RAX the value of RDI and only use RDI to pass the arguments to Tokenize, but I think with the system, it's fine to leave it in RDI. Maybe we'll change it later, but for now, I'll just put return. So it's going to compare space to our current character, and while it is a space, it's going to continue to increment and go here, increment, go here, and then when it finally breaks out, when it finds a character that's not a space, like the H, then we're going to return back up to the top. So Tokenize, the first thing it should do is actually skip white. So call skip white. And really, we should add a break somewhere. Let's run it and see what happens. So we click continue, do hi there, friend. So we have our, oh wait, I didn't do it the wrong way. I'm supposed to add a bunch of spaces. Okay, so let's see, let's add a bunch of spaces. Hi there, comma, a lot of spaces, friend. So if we run this, you see all of our nasty spaces here. So we click continue, and now 402005 was added as a first character. That's different. Before, it used to blindly do 402000. So let's see if that works out. We have 0, 1, 2, 3, 4, 5. So our H is that first member of the array. So that worked out very well. Let's click continue. We null terminate after the hi. Perfect. So hi is its own string and it's a token in our array. We click continue. And did we have spaces between here? I don't remember. We didn't. We just had hi and then there. So 402008, which is the T, is that second member. Perfect. And then we null terminate after the comma. There it is. And now we had a bunch of spaces before friend. So let's see if we add the F to that array properly. Let's see if we skip through the spaces and we wrote 12 in here. Is 12 the right number? I don't know. Let's see. 10, 11, 12. Okay, cool. So that solved the problem very easily, which is nice to see. So now we're skipping through all of these extra spaces and saving only the strings themselves. And we're still null terminating. So friend did get its null terminator here. Which I didn't notice before. So we are null terminating all of our strings. So if we try and print any one of these, we can print them individually. So they've been tokenized. Even though they started as one long string, now they're all split up. And we have our array full of them, right? This one points to hi, this one points to there, this one points to friend. So we have our tokens. So I guess what we need to do is do a bit of cleanup because we're still going to overwrite our old data here, right? Our loop is still a monster, still a black hole who's going to eat everything and do all weird. He's just going to go forever, overwriting himself, adding memory, adding addresses, overwriting, and then we crash when we went out of our space. So how do we solve this problem? We know that off the bat, we have a null terminator here. So what this means is the guy that's going to the end of the token, right? Find end. He needs to be prepared to stop if he finds a null terminator as well. So right now we're checking for a space, but we also need to check for a 0, right? For the end of the entire sequence. And if he finds that, then he also ends, right? He also returns. He doesn't just pass over a 0 like it's cool, right? He stops for a space and also stops for the end of the full string. But Tokenize is not going to know what condition caused find end to return to us. Is it a space or is it a 0? Well, after we call find end, we should also check to see if it's a 0. So we'll compare byte pointer RDI to 0. And if it is a 0, we jump if equal to a 0, and we'll just put tokenize.return or done or end or whatever you want to call it. So we can put here tokenize.end, and then our return is in here. And I think this fixes that little bug that we had. So let's see if this works. So let's click continue here. We do hi there, friend. Let's add all our weird spaces again. And we can't add spaces in between, right? Because we'll make more tokens, which I guess is fine for an example, but let's make sure that we end when our string ends at the end of friend. So we have our weird looking Frankenstein string now. We continue, we add that first 402000. It is an H, so it's totally fine to add that. We null terminate the high. We add the T, which is 7 here. That makes sense, right? 8 is the start of the next line, so 7 is that T. We continue, null terminate that. Then we're adding some weird value here, which is the E. Again, we put spaces here, so we have a bunch of weird tokens. But I just want to make sure it ends properly. So after we finally reach the end, then we exit with code 0, and I think that works. So right before we call exit, let's add one more call memview, so that we can see what's happening. And by the way, I'm just noticing high was printed out, and that's because we're calling print on buff. And if you recall in the beginning, when we printed out what was in buff, it printed out the entire string, but now high has become his own string. It's his own token. So I think this is working well. Let's run this test again. Hi there, friend. Let's add some weird spaces, but keep our 3 tokens. So we have hi there, friend. Made a nice little pyramid here. We add the H, which is 03. It skipped the spaces, that's good. We null terminate. We add the T, which is 9. Null terminate. We add the F. And then we print out hi. That means that we exited our tokenize, right? We returned out of tokenize, which was here. And now we're following through. We print what's in buff, which is now only a hi. Although, wait. Oh, right. It's not printing from our array. And our array is the one that skipped the spaces. We're just calling from the raw buff. And that's why. So really, if we want to print the first token, then we don't want to put buff anymore, because buff may not be the start of our actual tokens. Let's put tokens in RDI. And now we should see that even with the spaces, we should have it print properly. So let's add a bunch of spaces and then hi there, friend. And we can add some spaces here. Fill up our array, and then we're printing garbage here. So I made a mistake. That's very easy to make and happens a lot. Tokens represents the location 402080 of the array, but each member of the array is actually a pointer to the actual string. So we need to load tokens to RDI, and then we have to dereference RDI, and we can pass it to itself. So what we're going to do first is, let me put an interrupt here so that we can look at it properly. So we click continue, add spaces. Let's wait until tokenization is done, which I guess is right here. Okay, so what we want to do now is we want to print, oh, I don't have our stack is not the same anymore, but we want to print the first member of tokens. So we're going to load tokens into RDI, which we've done now, 402080. If you remember, that's the location. But if we're trying to print what's at tokens at 402080, it's going to be garbage data, because it's really a memory address that we'll be trying to print as characters. Each one of those members is the one that points to the characters. So now we're going to dereference it, and we have 402003, and that's the location of the actual start of our string. So if we click continue here, then we have hi printed out without the character, without the spaces, right? Without these spaces before, and we have our first token printed out. So that works really well. So let's make a function called print tokens, I guess. So let's put it here, let's call it print tokens. So let's use R15 again. Let's load the address of tokens. And then we're going to need a loop, because we're going to loop through them. Let's call it, I guess, pt.loop, just to make it a little easier. So what we want to do is make sure that the member of the array is not null. And we can see right here on the right, first we're going to look at this one, then this one, then this one. But if we have a null member on the array, right, something that points to memory address 0, which is what this would be in the context that we're using it, we're treating these as memory addresses pointing to the string locations. Since this memory is initialized to 0, the first member that we get to that says 0 is the end of our array. Now, as we add them to the array, we could keep track with some register or a local variable, which we have to cover on the course. Sorry, we haven't covered local variables yet. That should be very soon. But we could keep track, of course, of a count, and then it would be very easy. But we can just use the zeros here to know when we've reached the end of the array. So let us compare a keyword pointer, so a quad word, right, of R15. And remember, R15 is going to be the address of tokens, at least initially. So it's going to be this address here. So we're going to dereference it 402080 to look at this value. We're going to compare this value here against 0. So let me put the 0, or 0 is fine by itself. And if it's not 0, well, if it is 0, then we pt.end, I guess, right? And we'll just put pt.end return. So if the member that we're on is 0, we return. But if the member that we're on is not 0, then we can move to RDI, the dereferenced R15, right? That's exactly what we just compared. We dereferenced it in the comparison, but really we should move it to RDI. I guess we could do that first just to make it simpler. So we can dereference it to RDI, and then we can compare this directly, RDI and N0. I think this works. And if the dereference value, again, R15 is the one that actually is keeping track of the different array members. So R15 right now has the address of that first member. We dereference it to get the value. We put the value in RDI of that memory address, right? So the brackets are for. Then we compare that value to 0. If it is 0, we end. But if it's not 0, then we know that it's pointing to a string that we want to print. It's one of our tokens. So it's already in RDI. We don't need to do anything there. So I think we can call print, and then we can jump back to pt.loop. But before we jump back, we need to increment R15 by 8, right? To move to the next one. Right now, it's at 2080 and then 2088 and then 90, which is in hex. It looks like we went up by 2 here, but it's actually by 8. We have 64-bit pointers, and our array is full of pointers to strings. It doesn't really matter what kind of pointer it is. They're pointers, so 8 bytes. So we move up by 8 bytes to get to that second member. So let's see if this works. I feel like I'm going to do something weird here. Inc R15 8 does not make any sense. We need to add to R15 8. Okay, let's check this out. So let's add some spaces, test our features. Hi there, friend. And we have our original string. We add hi as a token. Then we don't terminate. We tokenize there, null terminate, tokenize friend, null terminate. And then we have reached, where are we? I think we're here. So let's click continue. And we have hi printed out, kind of scared to continue. And then nothing happened. I wonder what happened. Oh, I'm not calling print tokens. Okay, bummer. So what do we need to do? Print tokens does its own thing. We don't need to set any arguments. You could, of course, convert this to take those arguments, but right now it just completely does its own thing. It knows about tokens. You may want to change that yourself. Let me add one more int 3 here. Actually, memview is there already, so we don't need that. Okay, so we click continue one more time. Hi there, friend. Make sure it looks nasty. Populate our array, and we have it printed out. Hi there, friend. Now, there's no new lines between them, which is an issue, but it did get rid of all the extra spaces, which is very nice to see. So what I'm going to do is I'm going to copy this function here, and I'm going to make a version. I'm going to make a version called Println. And what we're going to do is print whatever was requested, but then right after that, let's print a new line character. So let's move RAX 1 again, and move RDI 1, and move to RSI, which should be our new line, right? And then move to RDX 1, and then we make a system call. So we need to set up new line. I'm going to do it in a very manual way. I'm going to have new line here, dot byte, the value of A, but you could put it in little single quotes. So where's our print line? Print, here he is. Okay, so we're going to now load to RSI new line. So we load the address, and then now what we can do is in print tokens, instead of calling print, we can call print line, and hopefully this does what I want. So we click continue, and we make it messy. There, friend. Okay, so we populate everybody again, and then we get to our print, and there we have our tokens. Hi prints out with a comma. There is our second token, and friend is our final token. So we have a fully functional tokenizer now. Let's see if it parses out all of our words. And it's going to be very long, sorry. So there's all of our data. You can see it is cutting through and null terminating and kind of tokenizing, which is cool. And here, let's see if it parses out all of our words. That looks good. We could do some edge cases. I'm sure there's many bugs here. If we click submit without sending anything, I'm assuming it's going to break. It kind of does. It puts a null terminator there, and it prints out kind of like nothing. So really what we should do is, after we call readline, we should compare RAX to 0. And if it is 0, then we can print like no data entered or something like that. So let's put S and then put like no data entered. Maybe we can put 2 new lines there. If it is 0, right? If rex is 0, meaning readline didn't read anything, then we can jump if equal, and we could just call it, I guess, like no data. And then no data here will be, I guess, load RTI. What do we call it? S no data, and then call print, and then call exit. So let's see if this catches that edge case. I have an issue. I did not put .ASCII. So we'll put nothing here and no data entered. So we have our little error message, which is nice. What if we put only spaces? I'm not really sure what will happen. And null terminates the spaces when it gets to the Fs. So the Fs are also throwing it off. Really, it should be zeros by default. So let's do that. We don't need this anymore. We had our illustration. Let's see what happens if we put spaces. Does anything happen? It does put something in there. So it's kind of a weird edge case. We really don't want it to do anything if it reaches a 0. So let's take a look at the logic here. We're calling skip white, and then we're assuming that after skip white has reached something that's not a space, right? After it's skipped all the white characters, we're assuming that it's going to be a character that is the beginning of a token. But if it's nothing, if it's just a bunch of spaces and a 0, then it should be pretty easy for us to check that. We're going to do the same thing here. We're going to compare, what are we going to compare? RDI, right? It's a pointer to 0, and it's going to be a byte pointer. So byte pointer. And if it's 0, if it's equal, then we're going to jump to no data. Same thing. And I think that should handle it. Let's see. We put a bunch of spaces, no data entered. Perfect. Although now this may mess up our regular program here. So hi there, friend. Let's see if it ends up saying no data entered at the end of that, because I don't want that to happen. Nope, seems to be good. And that's because when find end returns, that's when we check, and that's when we end our program. So I think this works out really well. Now, the whole reason that we're doing this, of course, is we want to be able to put in a command like echo hello world. And the idea here is that we'll look at echo and we'll see if we have a handler for that command. So we need to have a function to compare echo to another string, and that's, I guess, what we should do in the next video. We're going to build our string compare function where we can compare 2 strings. Maybe echo could be the first command that we have in our little baby shell program here, where we have a command called echo, and it will just print out anything that follows it. So this will be hello world separated by a space, not a new line. So that should be pretty good for the next video. But yeah, so this is our tokenizer here. It's a really, really important piece of utility software that really opens up possibilities for us to have a structured way of parsing text, which is used for something like a shell or a terminal. And of course, a compiler itself, where we need to break everything into tokens, and then we can start sort of going through them. And hopefully we're going to go in that direction. And one more thing, in the x64 playground, we never get the new line character. But if you're going to do this on your own system or on like a Linux machine or something like that, then you're going to see that you do get the new line character at the end. So in that case, you would need to, instead of just changing the last character to a 0, you might change that character -1. So you might decrement rex, right, to overwrite the new line character if you do get it. So it just depends on the system that you have. But the default behavior is for that new line character to be at the end of your string. Maybe this emulator will be updated by the time you're watching this video, maybe not. But just keep in mind that you might have an extra new line character that sneaks in there that you may not be planning. So you can overwrite that with a null terminator if that's ever an issue. Thanks very much for joining me. It's been very fun. We're getting to do some more interesting things now in the assembly. I hope it's not daunting. Please feel free to ask any questions if it is a bit confusing. But what we'll do in the next video is cover string comparison, and then we can start getting our shell program to launch 1 or 2 tiny little functions. So excited for that. Thanks again, and I will see you soon.